Okay, splendid. This will be part 3 of us going through TechNote 205, basically my favorite PDF available on the internet. If Bangs Laboratories needed, a microspheres cheerleader, I would volunteer. Okay, so this part is the end of the document. At this point, you should have a solid understanding of the different components that you are making your decisions with in creating this covalent coupling protocol. And then you should also have a general idea of some modifications that you can look into in order to optimize. But something that's really great about this document is that it provides an actual protocol for you to follow in the lab. It's not extremely specific, as in including, centrifuge values. However, as a starting point, it's fantastic. Now, first, I did want to mention, I'm going to scroll to the end here. There are a few different protocols depending on the type of microsphere you're using. So again, think about that functional group that's on the surface of the microsphere. And if you aren't sure which, oh, excuse me, it's actually in TechNote 201. 1 second, give me a quick sec. Okay, so if you are needing to have some more information before you choose which type of microsphere you'd like to use, TechNote 201, it's titled Working with Microspheres, has a great resource here where we can get a general idea about why people use the different functional groups on the surface of the microsphere based on their application. So definitely take a look at this resource if you need help deciding. Okay. Carboxyl modified microspheres. This one, if you remember, and the amine modified microspheres are definitely the most popular in my experience. And every protocol provides a list of reagents that you can use, and basically you're just going to see it's a lot of buffers. This is a buffer, and then the only other thing you're working with is this, which is your cross-linker, and this, which is the protein, the ligand that you're using. So for example, an antibody. This is a very broad explanation of what's happening, but this is going to be your microsphere. Now you can't connect it straight to your antibody with an available amine, so that's where the cross-linker comes in. In this circumstance, they're using the example of EDAC, and that's also what I used in my protocols. So by mixing those two together, then you can add in the protein. There's an extended incubation period. So this is a long experiment, just as a heads up, not as much active time, but an incubation period of up to 6 hours. You can even go over a day in order to get your produced results. So every procedure you're going to notice starts off with a washing of the microspheres. This is just a good standard practice that you should be doing in order to prep your materials, get rid of the solution that it was stored in, and really get yourself to ground base. So one difference is, depending on the microsphere type, is what you're mixing it in. In this circumstance, it's an activation buffer, and you should have all of these buffers prepared before you're doing your experiment. After you wash, this was a good example. So say this is your 2 ml centrifuge tube. This is what you're working with. Now, after you have your solution, and they actually don't explain this here, but washing means that you add your sample to a centrifuge. And so when you're starting with your sample, after it is in the centrifuge for a while, you're going to be left with a pellet, which these are your microspheres. And this is the solution you don't want. And so after your second wash here, it says resuspend pellet. Now, this is something you're going to see throughout all of these protocols. What resuspending the pellet means is that you want to use a pipette tip to carefully suck out all of the unwanted liquid. So then what you should end up with is just a pellet. And then to resuspend it, you're going to add in your next liquid. In this case, it's activation buffer. Again, I usually pipette mix carefully, a quick vortex, that should do the job. You can also do sonication. This is just one of the many areas that you have to decide what you're going to do. So the next step is to add your crosslinker. So we have our microspheres cleaned, they're ready to go. Then you're adding in the crosslinker. Short incubation period, we typically use an orbital rocker for this. Then we're getting a washing protocol again, but this time in a coupling buffer. So what we're doing is basically just washing, resuspending, incubating each time with different buffers in order to make sure the chemicals that are binding. So at this point, after the incubation period, we're imagining, okay, the microspheres should be attached now to the EDAC or the crosslinker that you're using. Now we need to clean out the sample and get it ready. So wash 2 times in coupling buffer and resuspend in 5 mils of same. This is going to be the same process here of producing a pellet, taking out the unwanted liquid, resuspending, and mix it with pipette mixing plus a bit of vortexing. At this point, ensure that the particles are well suspended. You want it to be evenly mixed. The biggest trick for getting good results with this process is to make sure to eliminate as much liquid as possible. So you're really just having a pure pellet. And then you need to make sure you're mixing things as much as possible. Next is when we add in our protein. This is the ligand. In my circumstance, it's antibodies, whatever you're using. And here, I think they made a good note, and this was actually something I was thinking about before, but if you're using a protein, you can use that equation that we went over in part 2 to figure out how many milligrams of your protein you want to be adding. Now here they say 1 to 10 times excess of calculated monolayer. That's a very big range, and antibodies are typically quite expensive, so you need to figure out what your balance is, but most likely you're going to be getting best results larger than 1x of your monolayer. In my lab, we typically used 1.5. I would be surprised if you wanted to go up to 10x excess, but they're giving you a big range here to give you a good idea that even though you've calculated a certain amount using that equation, there's a good chance you're going to need to put in more. Combined microsphere suspension and protein solution. So, you're just having 2 separate containers. This has the protein, this has your pellet that was resuspended. You're going to mix them. Okay, and then this is the long incubation period. React at room temperature for 2 to 4 hours with constant mixing. This is just a personal preference, but the longer the incubation period, the better. You can put it on an orbital rocker, either at room temperature or in the fridge. This is something that you can experiment with, but give those babies time to bind. Okay, and then finally, the final protocol. So at this point now we have a microsphere with the crosslinker with your protein attached. At this point, you just need to clean everything up, get rid of any self-aggregation. How do we do that? We wash it. Wash, resuspend in this time quenching solution. This is the third buffer out of 4, and mix gently for 30 minutes, orbital rocker. Wash and resuspend in storage buffer. This is your final step. So if you're going to be taking an aliquot of that to assess under a microscope, get a spectrometry reading from it. If you are going to be adding in blockers, this is all the point where it's happening. To desired storage concentration. Store at 4 degrees Celsius until used. Definitely, I would recommend checking the solution daily to make sure you're tracking how much self-aggregation is happening. And it's going to take a lot of time to optimize, but this is a fantastic protocol and it is the foundation of what we used in our lab to create immunoassays. Okay, so let's go over now the amine, and this is going to be a lot quicker because now you've got a general flow of the protocol. It's very similar for all of these, just with minor modifications. I'm not going to go through all of them, but these are the two most popular, so let's do these two. So let's just take a look first before we get into the reagents. You're going to notice microsphere, but instead of a carboxyl group, you've got an amine group. Now this time, antibody is the same, it has an available amine, but what crosslinker are we using? A new one, but same basic protocol. Amino modified microspheres, amine reactive homobifunctional crosslinker. This is cool. Yeah. Basically the exact same process though. You're just using a different crosslinker that can work with this microsphere type. Wash coupling buffer, your protein, quenching solution with primary amine source. This is basically the same thing, just have to modify it slightly, and then your storage buffer. And it's interesting here, I think this was interesting. The blocking molecule is technically optional. However, here they've included it in the protocol, and so this should be what you start off with. But we're going to notice the same flow. Wash, resuspend, incubate, rinse and repeat. Wash with the wash coupling buffer. Resuspend the pellet. Incubation period. A longer incubation period, which is cool. If you get into the dynamics of that reaction, it just needs a little bit longer. Always fun to learn about that. Okay, and then we start over. So at this point, we have the microsphere attached to the crosslinker. Now we're going to repeat, wash, resuspend in the next buffer on the list. Then we're preparing the protein in the coupling buffer, and then we mix them. Then we have our long incubation period, same amount as the other one. Finally, wash, resuspend, this time in quenching solution, quick incubation, and resuspend in storage buffer. So, as you can see, it's very similar regardless of the materials you're using. So the other protocols provided by this are for hydroxyl modified microspheres, hydrazide modified microspheres, chloromethyl. I believe that's it. They provide some great resources for recommended reading. There's a lot of additional details. If this is something that you're interested in or looking to develop your own protocol, I would read this more fully, but I hope that this short series has maybe just put TechNote 205 out there. I think it's a great resource, and especially if you're getting started in developing immunoassays, this is a really good way to not only follow an experiment and produce some results, but understand what's happening a little bit better. All right, well, thanks for watching.